Hello everybody. Hope all of you are doing wonderful. Welcome to this spoken tutorial where we will be learning how to build a ETL pipeline. We will be building this pipeline using Snowflake, Airflow, and AWS. As a data engineer, you will understand that how to efficiently extract, transform, and load data from various sources is an essential skill, especially in cloud environment. Whether you are working on a personal project or on enterprise level, this tutorial will serve you well. Let's break it down step by step so that by the end of this tutorial you will have a clear understanding of how to set up a ETL pipeline in Snowflake, storing your data in AWS and using Airflow for orchestration. Section 1. What is ETL and why is it important? Let's start with the basics. ETL stands for extract, transform, and load. It's a process in which we extract data from various sources, transform it so that we can have some business insight or some data analysis can be done on it, and at last we will be storing it on some warehouse like a Snowflake. In today's cloud dominated environment, ETL pipelines are often designed to handle large scale data, which might be called as big data, to manage complex transformation which support scalability. Section 2. Components of ETL pipeline. Now let's look at all the tools which we will be using for this pipeline. Let's start with Snowflake. Snowflake is a cloud-based data warehousing solution which has its components separate. Its compute and storage components are separated, which make it quite fast in the modern world. It is highly efficient in managing structured and semi-structured data and seamlessly integrates with other cloud services. Now, let's talk about the other tool, which is Apache Airflow. Airflow is a tool which allows us to orchestrate data pipelines. It's a great way to automate, schedule, and monitor our ETL pipelines and tasks, which in the language of Airflow is known as DAGs. You will hear Airflow refers to as workflow orchestration platform. It basically controls the flow of data between different steps of the pipeline. The last component would be AWS. We will be using AWS S3 for storing data, which is an object storage service given by AWS. We will also be using EC2 for compute resources and processing, and obviously we will be using AWS IAM for managing all these resources. AWS offers a flexible environment where we can store our raw data very cheaply before doing ingestion in Snowflake and manage the compute resources we need for processing. With these tools in mind, let us start building the pipeline. Section 3. Step-by-step process to build the ETL pipeline. Step 1. Data extraction from AWS S3. The first step in the ETL pipeline is to extract the data from some sources. Here, our data is stored in AWS S3. S3 is often used for raw data such as CSV, JSON, or Parquet files. Let's begin the extraction process. First step would be to create an S3 bucket where we would store all our data. Now upload your raw data into this S3 bucket. Using Python, we can access the data using Boto3 library, which interacts with AWS services. Now that we have access to the data in S3 bucket, we will move to the next step of ETL, which is transform. Step 2. Data transformation using Python and Snowflake. Data transformation is the process where we clean, transform, and prepare the data to load into Snowflake. This typically involves steps like filtering out irrelevant data, standardizing formats, and enriching the data by joining it with other datasets which might be required. Here, we will use Python pandas library for transformation, which is a powerful library in Python. Here, we will use Python pandas library for transformation, which is a powerful library in Python. Additionally, Snowflake SQL queries can help us redefine the data to next level. First step would be to connect Python to Snowflake using Snowflake connector Python package. Once connected, we will define the schema for incoming data. For instance, if we are working with transactional data, we will define the schema for transaction ID, date, amount, and so on. Number 3. Transform the data using pandas. This would be as simple as removing null values, doing some filter, and doing some validations, or maybe aggregating the data. Finally, we prepare the data for loading. Step 3. Data loading into Snowflake. Loading into Snowflake is luckily straightforward. We can use copy into command to ingest data from AWS S3, or directly we can upload into table of Snowflake through our pandas and Python codes. Here's the process. First, we will stage the data into Snowflake. Staging is important. It lets us review and control the data before finally committing it to a Snowflake table. Second step would be use copy into command to load the data from S3 to Snowflake. Lastly, perform the checks over loaded data to ensure data integrity. After the load is done, you need to ensure that data is queryable by running some basic queries over data. Section 4. Scheduling and monitoring using Airflow. Now that the pipeline is built, we need to automate it. This is where Airflow comes into picture. Airflow allows us to automate ETL pipeline to run it on certain intervals, maybe daily, maybe weekly, or even on the basis of some hours, just as per the requirement of business. The first step would be to define a DAG, a directed acyclic graph, which is used by Airflow to run the execution. DAG defines the tasks which need to be completed before the next task can be started. Always remember, a DAG is acyclic, which means a task can never depend on completion of the same task. Use Python operator, which can be used to run the Python code to extract, transform, and load inside Airflow. Finally, monitor if the pipeline is regularly and properly working using Airflow built-in logging and alerting systems. Airflow make it very easy to track whether the task failed or succeed and offers detailed logs for debugging. Airflow makes sure that our pipeline is reliable and can manage changes in data and schema without manual intervention. Conclusion. To sum up, we have covered how to build an ETL pipeline using Snowflake, AWS, and Airflow. This process involves extracting data from AWS S3, transforming it using Python, and then loading it into Snowflake for future analysis and querying. Airflow helps us to automate the entire process, ensuring that the pipeline runs efficiently and it can scale when the data grows. As you begin implementing ETL pipeline in your own work, remember the key element: automation, scalability, and reliability. By mastering these tools and processes, you can design a robust data system which can give actionable insights to your organization. Thanks for listening. Until next time, happy coding.